Hello and welcome back to another Binary Ninja live stream. Audio looks good. It's a different time. Good morning, everybody, or good evening, as the case may be. And let me switch over to our, to do it right? Is it this one? No, is it this one? There it is. Xusheng, good morning, or good evening for you, rather. How are you doing?
Good morning, Jordan. I'm pretty good, and yeah, I'm really excited to be here.
Sweet.
share some insights into the challenges I just solved.
I'm looking forward to it too. I think that was a great blog post you just did. Hopefully everybody else is excited too. And if they're not excited now, it's just because they're sleeping or they'll check out the stream later, I'm sure. First, username,
Yeah.
I saw one message in chat, so I think we're live. Let me know if you guys can hear Xusheng all right. If it sounds good, you can see everything, hear everything. And then we'll bring up, let's see, here's our desktop view. All right, we can see everybody. I hadn't done a video chat since we switched over to the new streaming setup. So let me know how that's working. And actually, I'm gonna bring up a copy of the stream over here, another computer, just to make sure. All right, looks good from here. Audio's good. Awesome. Thank you, Charles. I appreciate that. Great. Okay, sweet. So yeah, I guess Xusheng, you're the FlareOn expert. I've dabbled at it a couple times, but I've never actually finished it. So why don't you give a summary of what FlareOn is, kind of in your own words? Although I think most of our audience already knows.
So FlareOn is a CTF challenge. It's focused on reverse engineering and is hosted by the Flare team, now part of Mandiant, part of Google, which, yeah. And I wrote in the first sentence of the blog post as the FlareOn challenge is the Olympics for reverse
Yeah,
engineers.
yeah,
At least that is how I feel. Like, there are lots of CTFs like DEF CON, lots of stuff, midnight stuff. But for reverse engineering only CTF challenges, kind of there is nothing like FlareOn. Like if you talk about the CTF challenge that is only focused on reverse engineering, everybody thinks of
I
FlareOn.
agree. I agree. I don't think there's
And
anything else that's as popular.
well, that might change in the next year because uh, me and some of my friends are considering doing another one. But
I look forward to it.
yeah,
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 that'd be fun. Because I can't even think of. I mean, I guess there's nothing in the like CTF style. There's like the war game style, and like just for people who aren't familiar, war games versus CTF usually just means a war game runs for like indefinitely. It's always online. Like you can always do reversing.kr, right? Or pwnable.kr.
yeah,
Um, like these are just always up, and they're fantastic challenges, but they're not meant to be like a competition with a fixed time period. And so this is probably the only other one I can think of is specifically reversing KR, or like crackmes.de or crackmes1 or those kind of site where there's just always reverse engineering challenges. But in terms of CTF, yeah, I think Flare is it. And
yeah.
in fact, it's interesting they don't show up on CTF time if you're curious because CTF time has a rule that a CTF must be like less than a week or something. There's some like limited time period that they would only consider things. So that's I think why FlareOn doesn't appear on CTF time. I forget the
Yeah,
exact rules, but I would agree. I think it's clearly it is in the vein of it. In fact, the leaderboard is fun to look at because this is everybody who finished all 13 challenges, and this is the order they did it in. So like Jinmo, I, I don't even understand. Like, does he not sleep? Like, how do you how do you blow through all 13 challenges in less than 40 or less than or about 50 hours, right? Like that's kind of bonkers.
yeah. And, for past years, like the first guy typically finish it in a little bit over 24 hours, and this year they made it kind of super hard. So even the fastest people will take some concrete time to deal with them.
That's a good
So
measure. That's a good
because this
point.
is the
Yeah.
10th 10th event of this, it's like they already do this for 10 years, and they decided, okay, we are going to make it more challenging and more creative this year. Yeah,
Yeah, and so I think you're on here as well as somebody who finished all 13.
yeah. You can search for my name and
Yep.
yeah,
So
Vector 35. Yeah,
pretty good. That's 153rd.
yeah,
Which yeah, it's crazy to think that like there were I think I, I forget I saw a graph somewhere where they showed total 3,000 people who solved at least one challenge almost, and yet
yeah,
only like the top 10% basically finished. I think a little less than 10% actually finished all 13 challenges. So it's
yeah.
an interesting drop off to look and see like how people do. So okay, challenges themselves though. How would you rate this year versus last year?
Um, overall is better. I mean, more challenging and more creative as the permanents. But they did make something a little bit strange at challenge 3 and 4, which is a bit tedious and confusing. So many people just gave up there because they think the challenge is so long that they cannot finish it. And it is only the third one. We have 13 challenges this year, but the third one is really, really, really long. It has 8 parts. Like you have a flag, have
Yeah,
to validate, but it's separated into 8 checks, and each of them can be confusing and hard to deal with. But starting from 5, I would say the rest ones are generally great, and some of them are, I would say, gold. So
nice.
yeah, definitely a great challenge.
What did you like, independent of like, maybe how Binary Ninja did, but just personally, which ones did you find the most fun or the most enjoyable, like amongst all the challenges? Do you think they were particularly clever or interesting?
Yeah, I think the fifth one and the 13th one are the thing that I think, Biden Ninja really shine, because these are obfuscated challenges. And if you don't have a great tool, you will be having a hard time to even understand what the code is doing. Other than that, I mean, we just generally do a great job on all of the relevant challenges. I mean, excluding the,
.NET
um,
or yeah, other.
yeah, yes, stuff like that. I mean, I just doesn't really remember some outstanding challenges to overcome, or any urgent patches to make Biden Ninja work for any of the challenges. We just handle them fine, and things just just work. I mean, out of the box,
All right,
pretty
so
much.
so yeah, so this is but like was there anything that like you thought the challenge design in particular was like different or clever that you hadn't seen before or something that was especially fun for you?
Um, yeah, I mean, there is a MBR ransomware
Oh,
in the
interesting.
Nice challenge. It's something that really haven't touched before. I know a lot of theories about it. I mean, I know how MBR sector is laid out and how booting work generally, but this is my first hands-on experience with that,
Huh.
analyzing the code and breaking the crypto and decrypting all the file. And I kind of got excited when I type in the right key and see all the files get decrypted, and of course then I find the flag. But it's just kind of a new experience.
And I did see I think I saw somebody in the write-up of the author online, I forget if it was on Twitter or where it was, mentioning this. You said that was the 13th, the very last one that did that?
No,
What, which one was the MBR? Which one?
it's the nice one. I
Oh, the
think the
ninth.
nice
Okay.
one may not capture that much of attention. It's just kind of interesting to me from my perspective, maybe
I
because
get you.
13th one, the last one, is really just called catching all of the media attention. Like, everybody is talking about that. I mean, everybody who gets to that challenge is talking about that, and all the other challenges is kind of, okay, it's great, but it's not really as, like, it's as important as the last one.
Well, and you can see too, it's really interesting. Like everybody, once people made it through to 12, I think the vast majority, there's really only like 10 people that that got to 13 and didn't finish it. I think people really like once they made it that far, they're like, "Oh, I'm gonna get this done," right? Like they didn't want to get stuck
Yes.
there. As I guess same to be
Yeah.
fair with like 11 and 10 even too. Like which kind of makes sense once you've made it through most of them. If you had the time anyway, you want to finish it.
Yeah, and the 11th one is actually a crypto challenge. It's a weakness in the ISO crypto. I had to use some math to deal with it, and the official write up is like just 3 pages and has no mentioning of reverse engineering at all. It just explains the crypto,
All the
and
math, huh?
basically, yeah, yeah.
Cool. All right. Well,
It
let's
has a
go ahead.
sure, yeah. No, I mean, just back to the topic.
Yeah, no, no, I want to get the flavor for it too, and I think a lot of people who maybe didn't, do it or didn't have time to go and read all the write-ups appreciate just getting a good summary of some of the different ones. So I think that's great. And so just to show people what we're looking at here, we've obviously got our internal Binary Ninja Enterprise server that you've uploaded all of your artifacts to for the challenges where it made sense. Um, And so we can see kind of all the binaries and the BNDBs. We're going to be mostly focusing on, though, on the fifth challenge, Where Am I? And then the 13th, which was Yoda, right? Just because those had some really interesting obfuscations that we want to show off because Binary Ninja did, I think,
Yeah.
especially well with those. Which one do you want to look at first? And we'll look at the fifth or the 13th.
I think let's start with the first one, and maybe you want to download the whereami.exe from the server. That's
Yep.
the original binary. And also, I just want to point out that we're not going to do a full walkthrough of the challenge. That is kind of too long
You
to
need
do.
you
This
need
will,
sleep, and I need to to finish my workday. So yeah, we would spend all weekend.
yeah. So this challenge is has some interesting aspects. First of all, it has two stages. It's basically the code you are viewing will somehow decrypt the
Yeah,
code of
this
the
looked like,
first
there's like
stage.
a blob here. This all looks like
Yeah,
some sort of
yeah,
encrypted blob. One nice way that I like doing for this too is like triage summary, and you look at the entropy map, right? Like you can see this is a very highly entropic section, so it's likely encrypted or
yeah,
compressed or
yeah.
um, so that kind of makes
And,
sense.
and, and this binary is also interesting because it bears a signature of a particular company. Of course, the signature is invalid, but it actually has a signature. Although this is not relevant to the solving of the challenge, but I guess it's kind of, because the FlareOn CTF somehow mimics the workload of a typical reverse engineer analyst. So you
Yeah,
sometimes see a binary that has a signature of a particular vendor that is trustworthy,
yeah.
but if you validate the signature, it's of course fake because otherwise they had broken the cryptos.
Well, or so, I mean, sometimes that happens in real malware because they've stolen the certificate, right? Like that's a common
Oh
thing. So I
yes,
imagine that's probably what they're trying to kind of reproduce is like the feel of like, oh, it's signed because they stole somebody's signature to get past. Because a lot of the whitelisting products will require a valid cert. So rather than pay Microsoft and have to go through all that headache, they'll just steal one from somebody else that they've already some other software company they've broken into. Um,
yeah.
all right.
And also, so this challenge, when I started analyzing it, I'm kind of confused because I think the main entry point of the code may not be the actual challenge. I mean, as I said, this is probably another binary, and the author maybe just put his code into it, and it doesn't actually start as the main function. So when I start analyzing the code, it's very confusing. I don't know where the thing really starts.
Mm-hmm.
So I went to do some dynamic analysis, and this is one thing I want to highlight with everybody is we have integrated TTD into our debugger. So if you have not heard of TTD, it's actually a feature of Windows. It's called time travel debugging, which basically allows you to trace the execution of a binary and replay it um, to do the analysis. Now, this is not our invention. It's the Microsoft guys, you know, invented TTD. And what I did is basically I integrated this into Binary Ninja Debugger. So you can actually replace the trace within Binary Ninja Debugger. And the benefit is, of course, you have all of the familiar user interface with you when you debug the code. Because, if you work with debug directly, it's actually you just get a command line. Pretty much, you get a command line, and if you replay the trace within Binary Ninja Debugger, you actually get all of the control flow graph and also the IO lifting, everything you're familiar with just inside. So the first thing I want to show is how to do a recording. Jordan, would you please just switch to your desktop and just run the executable first to give people an impression of what it actually does?
Sure. So I'm going to go
Um,
ahead and just download the original file from the database. I'll put it on my desktop.
yeah. So this is a virtual machine, right? You
Cur
don't want to exit.
Yes.
Okay.
Yes, it is. It's a virtual machine with a snapshot from before I set up the debugger, and you can
Yeah,
tell
you
because
might want to whitelist it in the Microsoft Defender because otherwise it already gets nuked. You see.
that's funny.
Yeah. This is typical for FlareOn because, as I said, it mimics the workflow and also the daily job of a reverse engineering analyst. And many of the techniques you see in the binaries are those used in the malware. So, I mean, it's typical to just get caught and
Let's see if that whitelisting worked on it.
Yeah.
It's still there? It's still there.
Does that? Yes, it pops up a dialog, right?
Yep.
So, so I used another tool called Process Explorer to see what was happening. Basically, it creates a process of Explorer. You don't have to download that. I
Yeah.
just can just describe it. So it creates a explorer.exe process and injected some shellcode into it, and that shellcode pops up this
Yeah, so
message
if we were to
box.
look at this window, it would be an Explorer. It wouldn't be in where am I.exe, which I guess that's the where am I, like which process am I in? That's the idea is that they're injecting. Oh, and by the way, hey
Yes.
Fox, hey David, good to see you, and Carl, good morning, good afternoon, good evening, whatever time it is for you. At the moment, so if you're asking about TTD, that's a great question. So Carl's asking, are there good ways to do time
Yeah.
travel debugging? And I think I know of Revin has it used to be Tetrain. They were acquired by somebody else. It's a commercial product. They support reversible debugging and TTD style debugging with their own whole UI and a fork of QEMU. Oh, I guess they support VBox too. There's
And there are also RR from
right
Firefox and
Mozilla.
also Undo from another team,
Yeah,
but we haven't really integrated them into our debugger.
I think is
There
it
is a plan to do it. If you search for our issue tracker, you will see I created issue to list all of the products that we are interested in integrating with. You just go to the debugger repository and search for TTD, and you can find the issue.
it's actually gonna be faster to actually no, it's not even. I forgot it's not a plugin anymore. Let's go here. So yeah, and then Panda is the other one that has some trace debugging. It's also worth pointing out that there's sort of two different nuances to TTD. Most of them are trace based. So Panda, UndoDB, I think it's UndoDB. Isn't it called UndoDB? Do you remember the full name?
I think its full name is Undo. I mean, I'm not a representative of them, so I'm not
Yeah, yeah,
sure.
yeah.
But I remember it's called Undo, no DB. So
It's just I don't know why in my
um,
head, yeah, it's UndoDB, but it's just undo. Yeah,
you,
you're right. There it is.
it's actually the vanilla GDB even had support for that as well, but it's not implemented in a way that is not very efficient. So most people would say it's not possible to use it. RR and Undo, on the other hand, has plenty of optimizations, so they make the thing actually usable and quite performant.
Yeah, so RR I think is the one that's kind of a little bit well known. Undo is a little less known. Actually, here's go those issues. Let's search for TTD.
Yeah.
Let's see, RR maybe. Yeah, there it is. Time travel debugging. It's all spelled out. Oh, the tag is the label is TTD. Yep. So this is all the ones that we've talked about. Built-in GDB support, RR, Undo, and ES Revin, which is again formerly Tetrain, now eShard. Which has their own. I
Yeah.
think they have the best UI, like a built-in UI for doing it kind of out of the box, which is kind of nice. That it's like you can see the whole VM all in this one in one.
Yeah. Sure. Yeah. Let's just start recording a trace in Windbug. You
Yep.
just want to bring up the Windbug window because, as I said, the TTD is not our invention; it's a Windbug thing. So, to do a trace, you still have to bring up the Windbug window and do it from there. Um, Record a trace.
This one says launch supports time travel debugging here,
Oh
or
yes, yes,
okay,
yes.
so let's launch
Just click that
executable.
and select the file and check the record, something like that.
Yep, let's do this. So and just so people are aware, last night I went through the documentation, which is docs.binary.ninja. And you'll see under the debugging docs, if you just go to the user manual debugger and then look under TTD, there's a whole guide that describes the setup process. So this is just what I did last night up until this part. We're gonna do this part here in a second as we attach Binary Ninja to it. But first we're gonna generate the trace. So I've got that. We're gonna open it and then Record with
Check
TTD.
that. Yes, yes.
Okay. So that's it. Where am I? I'm going to configure and record. Okay, sure. Put it in the documents folder. That's fine.
It's fine. It could be put anywhere you want. And you just wait until the message box actually show up and just terminate the two of them.
There we go.
Yeah, you can. Yeah, okay.
Oops.
Yeah, you can wait for it to finish indexing. Oh yeah.
All right. So
Okay, you can close WinDebug now. I mean, just kill it.
just
Stop the debugging.
exit. And yeah. So now we should have all of these traces generated, right? So we have the IDX, the out, and the run. All right. So now in Binja, we can open up Where Am I?
Yep.
And I apologize for the fonts being a little weird. I was setting up remote desktop, and I don't know why the fonts look fine on the machine itself, but when I remote into it, like, yeah, they got a little weird up here. So, all right. And I think if now, let's see, going to go to the debugger settings. We're going to choose TTD. Now the input file though is the trace now, correct? It's not the actual executable.
No, the input file is executable.
Okay.
Yeah.
But the executable path?
Yes, the executable path is the .run file you just generated. Just for your information, the trace is a .run file, and
okay, the working directory shouldn't matter. I don't think we can give it something else. There's no command line arguments, so that should be it.
Yes, and you can launch it just in the same way.
Now here we find out if I missed any of the steps in my setup last night. All right, looks like we're attached.
Yeah. You see here, if you have used our debugger in the past, you will feel that the interface is exactly the same, and that is the benefit of integrating this TDD into Binder Ninja debugger. Is basically you don't have to learn a new interface or a new language or new thing. Basically, you just feel the same, but you are actually replaying a trace, and you can go back and forth. Jordan, would you please switch to disassembly instructions and just let people see what's happening more clearly?
Sure.
Yeah. I cannot see. Okay, so you can step forward, just press the button, just like usual.
Step into or step over?
Up to you.
Well, let's step into. Let's go into this call. And yeah, so we're just single stepping like we'd expect.
Yeah, and now when you want to step back, you can go to the console and just type T minus, because if you have used
T
before, you know
is single step.
Yes, it goes forward, right? If you type T minus, you actually go backwards.
Can I do T minus 3? Oh, I want to do one at a time, but I can't do up enter at least.
You can do T minus comma or maybe semicolon or something like that, followed by another T minus. I'm not a WinDebug expert, so not really familiar with all these advanced syntax. But this is how you can go backward and go forward and go backward. You can just type C and
just let it go. Actually, that reminds me, I just did it. I think I've mentioned this before in a stream, but there is one other reversible debugger, which I think technically you can buy, except I've never actually seen it since I left working for Raytheon, I don't know, 10 years ago. But Deja VM is another option, and they have very little information on the website. But it's like that's it. There's not even a single screenshot. And the reason I thought about that is because it actually supports what I was just trying to do. So I could actually with that you can do T minus 10 and it would step back 10 instructions. But that was my muscle memory from a long time ago kicking in. So okay, so I can also do, is it C or G? I always forget when debug versus.
It's G. Go.
Yeah, G.
Yes.
And can I do an address? I think I used to be able to do like I can hit Command Shift A and then paste that address, like go to that address. Yeah, so I can go to there. Can I do G negative to an address? I don't know if Windows TTD supports that.
Well, you can try. I mean, probably yes.
If I just do G, I wonder if I have to put negative in front of it or.
G minor space address.
Yeah, okay, yeah, exactly. That worked great. That's cool.
Yeah. So this is how you actually navigate the trace. And also, if you have a particular time you want to travel to, you can just use xclaim tt followed by the time, which we will show maybe later in this trade. So, well, I mean, what I did with this challenge is, as I said, I'm kind of confused when I do the static analysis. So I resorted to dynamic analysis, and the first thing I did is I put a breakpoint on the create process A because I know it launches the explorer.exe process, right? It, and so I think about I should add a breakpoint. It's called x. The function is called create process a stub. You just type bp kernel32 exclamation create process a stub. You can use the x command to search for it.
Oh, okay. So, can I just do create process and like it will search that, or you have to do the full name?
Yeah, this is Windowbug's problem. It's not really
Yeah,
what I can control, but if you have Windowbug muscle memory,
I
it
think
also
there
fits
there
pretty
is a
well.
way to search to wildcard match, but it's been too long since I did a lot of Windbug. I don't remember the syntax. Um,
Yeah,
oh, and hello, Mr. A. Academic side note: if you want to dig through the history,
yeah. So Jordan, you have put the breakpoint, right? BP kernel32.
yep, I just did now. So
Okay.
now go.
And just press G to travel to the point where it's yes.
No,
Where are you at?
it it's so the interesting thing is I don't see the symbol here, but it does say I'm at create process A stub and kernel 32, and the address does line up.
Oh, that is expected because you don't have the symbol for
Right,
anything outside of the main binary. It's
right.
inside of kernel 32. So the thing I want you to do is to switch to the stack, call stack. Sorry, call stack. Yeah,
But where is the
stack
oh
trace.
yeah.
Yeah. And you see here, we are inside of kernel 32 create process A, but the item on top of it. I mean, the first item, if you double click the PC of that, no, I mean in the stack
Oh,
trace.
sorry. You want to be into here or into here? Here.
No, yes, PC. You double click the next address. Yes. You see here, we are getting to somewhere inside of where mi.exe, but
Yeah.
this has no code defined. Why that happens is because the code is all dynamically maybe decrypted or somehow
But I could copy this and I could
decompressed.
go back to this point probably, right?
Well, I mean, yes, you can, but you don't have to. You can go to the next one and see what's happening.
Next one down
Yeah,
here, you
pretty
mean?
much the same. Okay, so then go to the next one. Yeah. Oh, you see here, you see some code that is actually in the original binary, which we
Mm-hmm.
have a function for switch to the graph view so people can understand what's happening. Uh, so once we switch to the graph view, we can see where it comes from. It's coming from this call instruction,
Mm-hmm.
right? Yeah, and here what I'm going to show you is how we can actually time travel back to the point of this call and get into the first instruction of the code that is being called.
Like this maybe?
Uh, yeah.
Did I type it wrong? Oh, I did type it wrong. I know what I did. There we go.
Yeah.
Maybe? No, this is now we're in career press to say, okay, so now let's try going forward to this point. No, I must have
You
copied the
can
wrong
always
address.
try go to the start of the trace by typing G minor a few times. You do that at the start of the trace.
Yeah, so let me, okay. So, okay, now I'm in create process A stub, and I can look at the stack trace. Now I can go back here. and I
And
want to.
you can actually just create, Jordan. You can just press the button step return a few times. There is a button for step return in the debugger sidebar. You can just press it a few times, and you will just be stepping out, and you will be getting to the instruction you are
Oh, I
seeing.
see what you're saying. Right, because I could step back until I return into here. I gotcha.
Yes. Also, you can just put a breakpoint on that instruction, and you go back. You just
Yep.
go in the yes, yes,
Actually, yeah. So
and
let's
do it
let me do
again.
that real quick. Let's see. Yeah, we can do it either way. There's a lot of ways we can do it. Step
Yes.
return. I'm getting end of trace reached. Hold on. Let me go back. We're at the breakpoint here. We're at the stack trace. This is where we
Yeah.
want to go. We're gonna breakpoint this address here.
Yeah.
I don't remember if I have to do it that way. So we'll. I
You
don't.
can press F2 to add a breakpoint. Actually.
Let's see. Do I have breakpoints listed here? I don't see it there. I wonder if I bypass. If I set a breakpoint here, Binary Ninja might not know about it. Um,
Yes. If you set a breakpoint in the command line, Ninja doesn't know about it, but it works. The
yeah, it
breakpoint
did
will
because now
work.
it tells me that breakpoints 3 and 4 match, so it knows that I've got. That's fine. So is it
Yeah.
BL and BD43? BL. Okay, so breakpoint disable 3. That's fine too. Okay, so now if I go back, there we go. Now I'm at exactly that
Yes.
point.
Not you can single step into the code and see what is the beginning of it looks like.
There we go.
Just
That's
do
a
a
good
single
idea.
step.
Yeah. So
Yeah.
NI or no SI. No T. It's been so
T.
long. It's been so
Yeah.
long. Keep using GDB now.
Yeah.
Yes, and thank you for the
Okay.
reminder about omniscient debugging, the prior term. Yeah, back in the day, that's what it was called.
Yeah. Okay. Great that it works. We're now at the payload, and you see the code is actually obfuscated, right? It's
Yeah, all these
very.
jumps and stuff. But I bet if I just go to like medium level IL
Uh,
and even high level IL will be better. Oh,
yeah. You
there
can
we
just go
go.
to the high level IO, and it will actually just.
Yeah, that's
Yeah.
much better.
Can you tell me what the EIP is, because I cannot really see that clearly.
It's just 8,000 or 80,000.
Okay, that's great. Oh, we do two different traces, but the address is the same. Um, so here are a few things you want to do here. First of all, as you can see, the code is actually pretty much simplified in the high-level IO.
Mm-hmm.
And if you go to that address, it's called 80386F.
If I go to 8,
Just press T and go to that. No, what I'm doing here is I skipped some analysis work here because typically you will have to analyze the code by yourself and understand it. But I'm just kind of skipping all that and just showing you where the RC6 constant is leaving.
okay, right. So you basically walked that chain of calls that we saw, and you got to this function, then you saw this unusual constant, and then you went and searched like the internet for that constant, right?
Yes,
And you get RC5 and RC6. So depending on,
yes.
I think like the number of rounds or something, it just determines whether it's 5 or 6.
Yeah, I mean, this constant value is used in both algorithms, but
I think if you do, yeah, I looked briefly when I was looking at your blog post. There is a way to kind of determine, but either way,
yeah. Yeah. If you switch back to the code and show the disassembly side by side with this high level, people can see how much work Find Ninja actually did automatically. Because if you look at the disassembly, not only this constant doesn't exist, even the stack variable is kind of screwed up. But we managed to track the code and actually tell people, oh, this is the variable, and here is its value.
yeah. So like literally 1 page of decompilation, even including all of the like low confidence like variable copies or whatever, is this disassembly. And you can, yeah, there's a lot of this like static, like constant unfolding stuff that you mentioned too, right? That Ninja has
Yeah.
long just done
So
out of the box.
So one interesting about this challenge because some of my fellow players, my friends are faster than me, and basically when I was still working on that annoying, very long third challenge, they already told me Band Ninja does a great work for this challenge, and they showed me a screenshot of a competitive tool that, you know, basically gets broken by the
You
excessive
could say
number
which
of.
tool it was. Which tool was it?
I mean, IDA and Jira both kind of
Yeah.
screws up. Yeah, because typically with this large of graph, like these many basic blocks, their layout algorithm can have a problem. Basically, you cannot see which basic block follows which one, and also their decompilation is not as great as us. So in other words, it's broken. It
Yeah.
doesn't help them. And
Car-
and I said people say they develop a script to deobfuscate the code, and they feel very, you know, they did a significant work. But just with Bind Ninja, you get all the work done by us, and you just read the code. I mean, if you look at the high level IO, it's pretty much actually readable to some degree, right? I mean,
Carl points out we also have the crypto scan plugin, which actually I haven't tried. I'm curious. So the problem with this though is that because we're working on memory as opposed to like a standard binary view, I don't actually know if that plugin will work or not.
theoretically, it should be able to work because as long as you are at this point and you run the plugin, and it will scan for all of the high level of the function, and he will spot this constant and will report RC6. And also, you can use kpa on it, but I don't know how well it works. Let's just assume it will work because technically it should be able to find it.
Yeah, I also don't want to have to reload the tab because I just installed some plugins require you to restart, but it
Yeah.
does recognize the combined constants of RC5 and 6, so it's I would expect that to work. Yeah, good point, Carl.
Yes.
So
Okay. So
so we can
one
call
thing I
this
want to show you.
maybe RC6.
Yeah. Now, Jordan, would you please switch to the disassembly and close the other pane?
Sure.
Yeah. We're still at the entry point of this code, right? Can you
Um,
switch to the current IP? Just go to EIP.
oh, yep.
Yeah, yeah. Okay, so so one thing that people might wonder, although it's not related to the solution of the challenge, because if you want to solve the challenge, you just go ahead from here. But if you're curious, how is the code actually where is the code coming from and how is it loaded from into this address? You can use a hardware breakpoint. I mean, hardware breakpoint emulated by TTD. You just put a BA, type it BA space
And then the current address.
W1. Yes. Just put a hardware breakpoint on this address. And the syntax is BA space W1, which means write and 1
And
byte
the
and the
size.
current address.
Yeah.
Yes.
Uh,
Yeah. And just a reminder, because this is not the live execution, right? It's a trace,
yeah.
and Windows actually just emulates the hardware breakpoint, and basically it will scan for the trace and look for any writes
So I can set that
of
BA and then just G negative, right, to go backwards until I trigger a breakpoint.
yes.
And that makes sense, but not the G again, G negative. And this should be, so it would be right here is where it wrote. This is probably the first time through this loop, and let's check ECX points to, yep, that address, exactly. So there it is.
Yes. Yeah. Now this is something that you cannot do with forward debugging. I mean, in typical debugging, you won't be able to find out where the code buffer is written in this way. Because
Yes.
by the time you get that breakpoint hit, all this code has been executed and you have no way to rewind back.
Ryan, no worries
Right?
about being late. That's what we're very, very early today. And so I also didn't give people a warning because I wanted to make sure we were all set up in time. But you can always catch the VOD afterwards. Yeah, so right now, Ryan, just so you're here, we're doing FlareOn. We're inside of Where Am I, which was challenge 5. And we just found like the decrypted loop. And we're using the time travel debugging trace to go backwards just to look at where that decrypt loop is. So this is, you can see all the XORs.
Yeah.
And then we found this little this is where we're actually
This is
writing
actually
each byte.
RC4.
Oh, interesting.
Yeah.
So it's decrypting RC4 straight into it. I wonder if there's.
Yeah.
You can see some.
No, the code we're viewing is actually decrypting the code buffer. And Jordan, you can do G minus again to go to the place where the buffer is originally loaded. So it's basically loaded from a resource and then decrypted by RC4. And if you do G minus again, we'll be getting to the point where it's being loaded as a resource.
Yeah, so now EDX is okay. So this is just a simple like resource loader, I guess, right? Where it's going to read.
Yes, and if you go to the caller maybe of this function,
it looks like EAX.
Just check the code.
It looks like it's this buffer right here.
Yeah. Yeah.
And then it's just so it's just going to load it into that address, and then the second one, which I hit G again to go forward, and now I'm at this is the decrypt loop. So let's see, let's go back, and if I was actually doing this, I'd do, and then just being able to quickly go back and forth between these is really great. So this is copy from resource, and then this is let's see. I wouldn't necessarily, the first time through, I wouldn't necessarily know this is RC4 just by looking at it. I'm trying to remember, is RC4 one of those that doesn't have like a standard constant or?
Yes. RC4 can be only recognized by the code pattern, but it's easier to recognize because this is FlareOn, and FlareOn is kind of obsessed with RC4, XOR encryption, and also RSA. So whenever you see something that looks like crypto, it's already 95% that you can guess it.
It's not too big, thankfully. Yeah, like you could look at this. I'm curious what it looks like in high-level IoT.
And also, if you're just solving this challenge, you don't have to know this is RC4. You just get the original buffer and the decrypted buffer and drop down and this is super easy to do with time travel debugging because you never miss anything. If you press a wrong button, you can just rewind it a little bit and you get whatever you want. And also, when you want to dump a particular buffer, you don't have to worry about whether I miss the correct point to dump it because I can always go to anywhere in the timeline. Oh,
here we go. This is one thing Carl mentions is that this is a very common pattern in RC4. Welcome, Durka. No worries about being late. Like I said, we're early. Yeah. So this right here. So this is the state array actually. In fact, I think if I just hit S, okay, so it doesn't recognize heap alloc. But I assume is that the address where it wants to,
Oh, so okay. So Jordan, so these are API imports. And if you want to find out what it is, just use the ln command. Ln is least nearest. Just copy the address
at here or at this one here.
Use the address of this code buffer. I mean, you can actually press Control C on that token. You will be copying this address.
Oh, right, that's true. I don't have to go there. I was at Control Shift A, but yeah, just do so ln there.
Yeah, you can select whatever you want, and it will just give you the what you're doing. Okay. Yeah. And once you get all these named, you can understand this code is basically just doing a remote process injection. Basically, launch explorer.exe, allocate a buffer in it, and write some code into it, and just create a remote thread. I think let's fast forward and skip this part because it's just very typical reverse engineering. It's not super cool.
I'm just getting rid of sniped trying to create structures. Okay. Back so this is the loop. If I go forward again, I'm gonna get okay, so this was the call. Actually, that makes sense. Now we can see, obviously, we decrypt it and then we immediately call it. That's the very first thing we did at this high level function. So that was the call into our buffer.
Yeah. I think we can move to the next stage of this challenge. So the next thing I did is I dumped the buffer that it injects into the explorer.exe. And for the sake of simplicity, I already have that on our enterprise server. so you can actually stop debugging this
So now
and just copy that.
this is the so the code that has been decrypted is the injector, or that is the code that is itself injected.
We are looking at the first stage, and the first stage injects the second stage. So the first stage itself is encrypted and very obfuscated, and it's very confusing as we see earlier, right?
Yeah.
And what it does is actually it only injects the second stage into the explorer.exe. So
there we go. So now yeah, it's going to slowly build the analysis up of that one. So instead, we're going to open up.
Well, we can also definitely dump the buffer from the trace, because if you put a breakpoint at write process memory or something, you can of course dump it from there.
That makes sense. Yeah, we got the other challenge to do, so let's go ahead and just open that up now. So is this dump copy?
Dump fix.dll.bndp. Just download that and switch to hex and pretend I haven't added any annotation. And go to hex view.
Yep.
Go to no, sorry. Go to the PE view and go to the reflective loader.
Sorry, go to the PE view, like right here.
Yes, and also in assembly, search for PE reflective loader. It should be the first function. Hey, what we're doing? No, I mean symbol list, function name.
Oh, right, sorry.
Loader.
There we go. It's already highlighted. Okay, gotcha.
Yeah. So
where did this? So this name is this one you gave it? You gave it this name then? Because this wouldn't have had.
No, it's actually the buffer we dumped is actually a DLL file, but in a slightly modified format. And what we are seeing is what we will get after I fix all of the stuff. Because originally we just say it writes a buffer into the explorer.exe and creates a thread to execute from a particular point, right? We don't have all these nice PE view markups. But upon analysis, I realized this is actually a PE file, and I managed to fix it up. And you can just scroll down. Now you can switch to the hex view and show the start of it. I mean the hex view.
Right here.
Just show,
yes. MZ. Yeah, we see the MZ magic.
Yeah, this is not a typical PE structure, right? The PE header wouldn't typically start from the byte 2, but
right.
For malware, this is kind of normal, or just at least not unheard of, because of course the FlareOn guys or the challenge author doesn't want me to realize, oh, this is a PE file really quickly. They actually tweaked it. I'm sorry. I think I asked you to download the wrong file. You should be download the dump-copy.exe. That is the original buffer. Yeah, you just download this file and load it as hex.
Yeah, that's what it does by default. This is it.
Yeah, you see so the challenge actually modifies the header. The magic it's not having a PE and MZ at the start. It's having some random bytes in unit. And if you switch to the reflective loader, you will actually see that the code is looking for these two constants.
I'm curious. I was just curious if it was a constant XOR key, but it wasn't.
No, it is not.
So that reflective loader here. Oh, this 43F1.
Yeah.
Yep, there it is.
Yeah. So what I did is I patched the magic bytes to MZ and PE so that Binary Ninja can load it.
Oh, it's 1337 too. Sorry, I just noticed that the second constant is 1337.
Yeah.
I gotcha. Yeah. So, and then once you did that, you got like the actual PE analysis automatically.
Yes, and then you will also see the reflective loader symbol. I mean, it's kind of, I think they intentionally not remove it, just give you a hint, because if you search this on GitHub, you actually get a repository of where this code are all coming from.
Yeah. Oh, it's even fewer too.
Yeah. And basically what this code does is basically it loads itself. So it's part of the DLL, but it will first find its header and then do the parsing and just allocate all of the sections and then handle the control to the
Yeah, so you don't have to write
real
entirely
engine.
standalone shellcode. You can write sort of a real library and then add this to it so you can
Yes.
get it loaded in more
Yes.
easily.
Yeah, and this code is actually quite long, but it doesn't take me a long time to analyze all of them because again, this is FlareOn. Whenever you see some code looks like this, your instinct is to think of whether this is a PE, and this time I'm correct. So I save a lot of time. Otherwise, if you have to analyze all of this code, I'm sure it's a concrete work.
Yeah, that was a good observation to figure out that we're going to make that a
Yeah. The next thing I want you to show is you can maybe show the main function of this DLL. I can't remember how I called it. This the
yeah,
last piece of
you
the
called it
thing.
main.
Yeah.
Oh, and it makes sense at that load address, yeah. You've got a bookmark there on it, even.
Yeah. If you switch to the high level IO, you will see just scroll down a little bit and find a call to message box A. It says heard there is a RC6 somewhere. Where is it? Just go further down a little bit.
Oh yeah,
Oh
heard.
yeah, you see here. Yeah.
Yeah,
This is actually a hint, but a Binary Ninja user wouldn't need it because they would have already seen that constant
that constant, yeah.
earlier. And yes,
It's interesting that we
um,
didn't see that text. Um, it's a separate
popping
message
up.
box. Oh, because it's looking for is the username. Oh yeah, you have to be
Yeah,
running as the Flare user. So this is some of the other like checks that they've got on it. I
yeah,
assume this is just
yeah,
like an inline string copier. So it looks a little more than that, or string compare. But
yeah. Okay, all right. So this is what I want to show for challenge 5. Not going to do a full solution here because it's still very complex even from here. I mean,
yep,
we showed how to handle the obfuscation, but if you want to solve it, you still have some concrete work to do.
yeah.
Yeah, let's move on to the 13th challenge, which is the last one. It's also the most challenging one.
I would hope so, being the 13th one. So let's go take a look at that.
I would like you to first load the default setting one,
Yep,
because that is what you get.
just out of the
Uh,
box if you just open it up.
yes, out of the box, and yeah,
Not much, very immediately.
yeah. You can see this binary is actually heavily obfuscated, and is the entry point. Well, I suggest you switch to this assembly again because
Yeah, I am.
before all of the fix, it will just look doesn't make much sense.
Yeah, in fact, the
We
very
switch to
first, is this the entry point?
the binary view, graph view. Maybe no, that is not the entry point. Go to start. Man. Yeah,
No. No, that's not what I wanted. Underscore start. There we go. Okay.
yeah. Uh, um, how many functions has been analyzed? I mean, um, can you show me the progress?
It says it's done. It's got 14,000 functions analyzed.
Yeah. That is insane because this binary only has a few functions, and we get this many functions because it's obfuscated and it is screwing up
Yeah,
our
you can see all the
um
addresses are very close to one another, right? So they're only like 10 bytes
yeah,
apart or 60 bytes apart.
yeah. So okay, let's click the first function call. Just follow the first function call.
Oops, sorry.
Yes.
Starts. Okay, so start has this. Yeah, we do see a lot of these jumps like attaching the basic blocks, kind of what we saw before too in 5.
Yeah. And this is actually causing a lot of problem for IDA as well. I mean, people complain. You see these basic blocks are actually not adjacent. If you
Oh, the
switch to
addresses.
the
Yeah.
linear view.
Yeah.
Yeah, it's actually scattered across the binary. And I would say this is an effective obfuscation, at least it hurts IDA, because people say, oh, I cannot see a graph of the view. And because we will be seeing a graph that is too large, maybe have over 2,000 basic blocks in it. And IDA will just refuse to lay out it.
Hmm.
And you can only read the disassembly. But again, the problem is the basic blocks are scattered everywhere across the binary. How you
So
are
you're
going to,
constantly jumping around, it's hard to work up an
yes,
understanding of it. Yeah.
yes. I have a few friends that they say, oh, I write a script, fantastic script to handle this basic blocks and create a same binary. And I just say, okay, look at Binary
So
Ninja. We just
here's
need
like
to
a
do
stack
anything.
string, right? You can see it like slowly
Yeah,
making a stack string.
yeah, yeah. Now this is the first problem we need to tackle because the code is actually correct. Would you please go back to the graph view? Yeah,
Yep.
you see here, the pattern repeats, and I can tell you it repeats thousands of times for sure. And you cannot really just,
Yeah, you're not going to click one block at a time to get a single instruction, basically.
yes. And how to fix this is basically you want to turn off tail call analysis. Now, tail call analysis is actually a good thing in general. I mean,
For most
that we
functions,
do,
yeah.
yeah, to discover, to handle the tail call. Now, this is not a programming class. I'm not going to explain what is a tail call. You can Google it. But here, what we want to do is just disable both of them. Yes, disable both of them. And also, you want to disable,
Oh, linear
okay,
sweep.
you already open. Yeah,
That's
linear
fine.
sweep as well, because the linear sweep is creating
Yep.
too many functions that is fake.
So I could just open yours over there, but I'm going to go ahead and do it just to show the full process. I think it's
Yeah,
worthwhile. It's nice that no, that's detailed linear sweep. So let's disable tail call, and then we'll search for just sweep and auto run point. Nope, not that.
no, you screw up. You just screw up.
This one.
Just search for linear sweep.
Yeah,
Yes,
auto run
auto
linear
run.
sweep.
Yes,
There we go.
yeah. And with all these settings disabled, we will get at least not crazy binary. Yeah.
I think I did something wrong. What did I miss?
Um.
Still.
Oh, you are opening the database. The functions are already there. They
Oh,
won't
you're
go
right. You're
away.
right. You're right.
Download the just open the original binary.
Yeah. So let's see.
Open the
Download original file.
.txt.
Just
Yeah.
it'll show it.
No,
Here.
this.
It
Yeah,
is
open
nice,
with
by the
option.
way, that Enterprise directly opening doesn't trigger the virus protection. So we were working with it
Yes.
in Binary Ninja without triggering that, which was quite nice. But so if I open default settings, yeah, I know. I'm going to allow you.
Yeah.
Okay, so
And
now
these days, Windows Defender is getting hard to fully turn off.
let's turn off that. And now let's open the file. There we go.
Yeah.
So now we've got our entry points, and it's taking a little bit here. So that is one. There we go. Okay, so this looks far more interesting.
Yeah. Okay, you are in that large function, right?
Yep.
You want to check how many basic blocks are there in this graph, in this function. Just len list current function
Yep.
dot basic block. I remember it's 2000.
2,457. Yeah.
Yes, yes. This actually breaks idle brutally, I would say. And you can see the last stack string is really, really long. You see the scroll, the scroll bar is really, really long. And that is actually just a ASCII art, which gets printed when you launch the binary. You see,
Oh, this one right
there
here.
is
I'm sorry, I see what you're saying. Yes.
this is a really, really long string, which consumes most of the basic blocks. but that is just the ASCII art,
Hmm.
which prints out when you launch binary, and it absolutely has nothing to the solution of this challenge. So a wise optimization here is to patch the code to remove it, but you don't have to do it because we can handle it just fine. I mean, you don't have to patch it.
Yeah.
But if you want to, for example, it's your work, you have a malware, and you certainly want to patch them because it's useless. It just consumes your CPU cycle, and it doesn't actually do anything. But it's not a problem for us. We just can't handle that. Okay,
So would
so the
you,
next thing I
like,
want to
if you were
show,
going to patch it, would you just literally go to this this basic block and instead of jumping to the next one, just go find the end of that string and jump to that, or like how did you?
yes, that is what I did.
Okay.
But I forgot the addresses, and if you can find it, you can do it. I cannot see that text clearly, so
No,
I'm not
it's no problem.
forcing you
Let's
to
see.
do it.
I could let's put a bookmark. We'll call this bookmark one at the beginning because that's that space at the beginning of the string that we see right here. And then I can probably just scroll down like this
To the
whole.
next instruction in the high level IO.
Oh,
You
that's a
just
good
click,
suggestion. Yeah.
yeah.
Oh yeah, that's perfect. And then there's a 0A 0D. Yeah, so there's the new line. So we could actually just have it go right to the null pointer. We want it to go right to here. So let's go bookmark
You want to
one.
keep the move, maybe. Well, it's up to
That's
you.
true. That's true. I want to go to this block. So I'm going to go from the first space to this
Okay.
move the null. So this address we're going to copy, and then we're going to go back to bookmark one. And then from here, we're just going to edit this line to go to that address instead.
Yes.
I have to do that. And yeah, that makes our whole basic block much easier to read.
Check the number of basic blocks. I remember it's going to be 500 or so.
Yep, 498.
Okay, great. Now it's going to be slightly more performant. I mean, it's slightly faster to do all of the analysis.
Yeah.
And the next thing you will notice is a bit hard to diagnose because we see all these question marks saying the stack is screwed up. And so the problem here is once the ASCII art is created, you see a function that is taking a weird hash value in R15. Jordan, would you please find that?
It's right here. Well,
Address.
it's in fact what it does is it looks like it does a pop R14, pop R15. So there's some pushes
Yeah, that
earlier
is
up.
actually API hash resolver. Now this is again it's FlareOn. They love this trick because
Yeah.
malware authors all love this trick. Is basically when they want to call the API function, they won't call the API function directly. They will have a hash value for it, and they will go through all of the hash API functions in a DLL and hash the names of it and look for a match. And once the match is found, they will be finding this function, right? Now,
Yeah, and Binary
here
Ninja,
is
because the basic block's being split up, I think Binary Ninja doesn't know the number of arguments to this function because it's like directly manipulating the stack, maybe?
no. The problem is this function is actually screwing up the stack. So it's a bit hard to explain here, but if you set the stack adjustment to -20 for this function, the stack will be fixed. The problem is, this function is,
20 hex?
-20. -20 hex, yes.
Okay.
Oh, before you do that, you want to first switch to the text.
Switch to what?
The text, the sidebar, text at sidebar.
Oh, I see what you're saying. Yes. So we can see all the unresolved.
Yeah, all these. These should all go after you fix the stack.
We lost some of them. Did I do...
The analysis is still running. Once it's finished, it should
Oh,
be
I see.
all
You're
gone.
right. Yep. There we go. Oh yeah, and now I actually
You're
see
using,
all the
yeah.
cross references. I see there's at least 2 arguments to it. Yeah.
Yeah, and you see what's even better is Binary Ninja now starts to understand, oh, this function takes argument in R15 and R14.
Yeah. And I just see these, and these are constants that don't they do exist directly. Okay, so these are assembly. These ones are not done through constant unfolding.
Yeah, these are just values. And now we're going to introduce a very cool thing to deal with these hashes, the HashDB service.
Yep.
There is also a plugin for it called HashDB BN. I assume you have already
I
installed that,
installed that
right?
one. Yep, Cindy's plugin.
Yeah. And what you're going to do here is just select the hash and right click on it. Now let's pretend we don't know what hash it is, and you will need to
Yep.
hunt for it because there are tens of ways of hashing the API function, and how do you know which one it is? And you just select one of them and ask the plugin to hunt for it,
And the one that
and it
I
will tell you
found literally only has one. Sometimes you could get multiple. You might have to try different ones,
yes,
but
and you just try multiple hashes. Now this time, Jordan has great luck. It's Metasploit, and you just click accept, and it will set the hash. Yeah, click OK. Yeah, and again, right click on it
I can do a
and
single
hash
hash
DB.
lookup on that particular one.
Yes,
Look at that.
yes. And the plugin is well written because it will also ask you whether you want to import all of the hashes for zip DLL. Because otherwise, whenever there are 100 hashes, you will have to click it 100 times, which is a bit
Yeah.
repetitive to say at least, right? And this plugin, just click OK. Yeah, and go to the types sidebar. Show
There they all are.
yeah, you see it imports all of these, right? And once the analysis finish,
I should be able to
you
set
want to change the type of
the
this
second
function to
argument. Yeah.
yes.
There we go.
Yeah. Some of them should be already showing the names of the API function, right?
Oh yeah, I see the library A. I see virtual alloc.
Yeah. You scroll down a little bit, there are still some missing ones, and then you select one of them and just do the same for the lookup.
Okay, yeah. So let's do HTTP hash lookup because that's a different DLL, so that makes sense. And now, does it
Yes.
add them to the same enum? Yeah, I assume it does. So
Yes.
it should just do reanalysis, and then yep, WSA startup. And actually, I can just click. The easy thing is I can just click that function. Look at all the cross references right here. This is also really nice. Find any hashes I don't yet have, and then look that one up.
Yeah. Now, with this annotation, we can already start to understand what the code does roughly. I mean, right? We see it calls virtual alloc and bind, WSA startup, stuff like that.
Yeah.
Some of them doesn't work for a bug, but we just pretend we don't say that.
Send. Okay, so we're back in our main now. I think we've got all of those marked up.
Yes. Would you please close the disassembly and just show the high-level IO?
Yep.
Okay. So the code is actually becoming a little bit more readable because we know which API functions are being called. But this binary, is the last challenge for this FlareOn, and the last challenge is typically challenging. It's large, long, and only knowing the API sequences doesn't help you solve it, or at least not in the fastest way. So the next thing I tried is to basically let Binary Ninja know the types of these API calls.
Mm-hmm.
Because if you have a binary that is compiled in the regular way, Binary Ninja will be able to know the prototype of virtual alloc and will tell you what is the size of the buffer and what is the permissions, right? But it doesn't do it right now because it doesn't really understand this API resolver, at least for now. And what I'm going to
Yeah,
do
it just
here
sees this
is
as a void star when it's actually a pointer to
yes.
virtual alloc.
Well, what I'm so my strategy is like this. Now we know what API is being called, and we have type libraries, so we can actually write a script to pull up the information from the type library and apply it on each call site. So now before we run the script and show the result, we can show actually how you can do it by hand, one by one. Jenny, would you please switch to the code view and just right click any of the calls and say show override call type?
So not on the resolver, but so am I overriding one of the resolvers or am I overriding?
Resolver. Yeah, you just select the line of the resolver,
Okay.
the API resolver token, and
Yep.
right click override call type.
Oh, yeah, I see. So we're gonna change. So right now we just have the two arguments, but we're gonna say
Yes,
actually it takes other arguments that are gonna go to virtual alloc.
yes. So this is a cool feature of Binary Ninja. You can at each call site you can set a different call type of the function, and it only applies to this particular call site. Like even if this function is called like maybe 50 times, and all of the other ones won't change, and only this one will have the type you set, which is perfect for this case because otherwise you can actually rewrite the IO and have the most readable, most correct way you want. But writing a workflow to rewrite the IO takes a while. And using this override call type basically just is instant. You can write a script to do it, and maybe you want to bring up the script and briefly explain it.
Yep. So all right, let's see this. We could have manually just now put all arguments, for example, for virtual alloc here, right? Like just added them.
Yeah.
We go look up virtual alloc's actual parameters and go added all these types. Or
Yeah.
let's look at your snippet. So I've already loaded the script that you wrote into the snippet editor.
Yeah. You want to start from the bottom, basically. For each call site of the function, what I did is basically just first resolve the API function. Again, I mean, we already have the info by that plugin, but that plugin doesn't help us which DLL is it from.
Yeah.
And that is essential for pulling the type library.
Yeah, the
So what I
plugin
did here
had that
is
information because it used it to create it, but it doesn't like keep it around anywhere and that we can access it. It just
Yes.
adds it to the enum.
Yes, but calling the HashDB API is really just like 5 lines of code.
Yeah,
and
it's pretty nice.
we have the name and library. And the thing
Yeah.
I did here is bv.platform that get type libraries by name. And
Yes.
that will pull up the type library. And the next thing is called bv.import library object on it. Now, here is one thing that why you wouldn't want to do it by hand. Of course, you can Google and find the prototype of virtual alloc, but you probably won't be able to apply that directly
Yeah,
onto the
because all of the other
line.
types, all of those types, for example, like I don't have necessarily like LP void
Yes.
just in a random blob that I've got. Yeah, you need all the
Yes.
dependencies.
And bv.import library object will recursively look up all of the dependencies from the type library. So now you call it on virtual alloc, it will actually import all of the enums, all of the types needed by itself. So it saves you a lot of effort. And by the time you get the return value, all of those are actually already added into the binary view. And then I played some text processing, basically changing the prototype of a function a little bit, because otherwise I would have the arguments, but I would lost the name of the API function.
Mm-hmm.
Think of it, because if I see virtual alloc has 4 parameters. If I apply the original prototype of that, it's great. We know which is the buffer, which is the size, but we don't know it's virtual alloc. So what I did is I write a short function, basically adding R15 as the second argument. And now an official way to do this is to use the function builder, but I think it's kind of complex because you have to set 10 properties of that.
Yeah.
So here I just use text processing, and it's quite effective.
Yeah, I mean it's like 11 lines of code, really, right? Like and the main loop, and then your text processing here is just another like 7 lines of code.
And another thing I want to explain is why I have to set stack adjustment again at every place. I already set it on the function level, right? But the problem is in our analysis pipeline, if you have an override call type, it will also override the call stack adjustment of the function. Now this is I would say it's a feature more of a feature than a bug, because if you override the call type, the stack adjustment previously set is probably also invalidated,
Yep.
right? Although in this case you want to keep it, but we have API function for you to use it. Just reapply the stack adjustment at every place, and now you still have the effect of the correct stack adjustment. And again, the last thing I want to say is you always want to bv.begin on actions and
Yes, wrap
bv.commit
any
on
changes you
action.
make. That way I could run the script and then hit a single undo, and it would undo all the changes that I
Otherwise,
made.
basically, you make binge on either, because you won't be able to undo. That's very bad. If you
Yeah,
have some benign changes you want to keep and you corrupt it, basically, not all of the things we have done you have to redo.
that's a
I think
really
it's
good
time to
summary.
run the script
I agree.
and show how. Yeah.
I'm going to go ahead and even, we're already going to print out for each one of those cross references, so that looks good. That'll give us a little bit of
Yes,
debugging
and
information.
you want to make the code views a little bit slower, a little bit smaller, because as the script runs, you will actually see the hello file just change in real time. So you want to show this hello file, and you see all those parameters will be popping up as the analysis goes.
Sometimes I just hit space twice because sometimes you refresh the view. So, and yeah, sure enough. So low level A has this one. Virtual alloc has all these
Yeah, it's
parameters. Oh yeah, look at this. Even
yes,
these
you can
enums
see.
here. Yeah.
Yeah,
Create pipe. Yeah, so significantly easier to read now.
yeah. I think it's just like it's as if it's not obfuscated at all.
Yeah.
Pretty much I can say that, because once I get this script down, I solve it very fast, faster than many of my fellow players.
And remember, like looking at the disassembly, right? Like all of these basic blocks all over the place. Like this is a nightmare to
Yeah,
like look at the actual disassembly level. You would not want to look at that.
yes. This assembly is really not for
That's
human
pretty
in this
useless.
case.
Yeah, yeah.
Yeah. Yeah, that's pretty much what I want to show for the 13th challenge. And of course, starting from there, if you want to solve the challenge, there's still concrete work, but at least we have a readable code that people can work with. Um, that's something that don't make people mad. And also, if you do some markups for the virtual allocs, like the first virtual alloc is actually allocating a global buffer. If you use the smart structure creation for that, you will make the code even more readable.
Yeah, it's just so much nicer. So this looks like a cleanup. We're closing and freeing a bunch of stuff. So I can call this one cleanup. And then yeah, you can see like our clean up and exit probably is.
Yeah. Now you immediately see a global structure which is hex 58 bytes, 58 inside bytes
Yep.
inside,
Yep.
and then we allocate 3 buffers, and they are saved in the structure. And just like the code is not obfuscated at all. I mean,
Yeah.
not many people get this privilege to read this clean output when they play the challenge. So
Yeah. So
one
this.
of my friend, which is pretty much an advanced user of Python Ninja, um, attempted the same thing. The same thing as I did, but unfortunately, he doesn't know how to fix the stack adjustment. So he has to read the code. It's still much better than IDA, but it's kind of out of sync. The variables are out of sync,
Yeah.
and yeah.
That's very nice though. Yeah, it looks really good and it's really easy to start cleaning this up. You can see those other virtual allocs get thrown into pointers in that global structure. So there's those other 3 buffers, and then you got to go figure out what that does. But that's left as an exercise to the reader. So that's the rest of the challenge there. Awesome. Yeah, thank you for hopping on the stream. I know it's a late night for you, so I appreciate you doing that. And thanks again for doing this and writing the blog post up. Yeah, this is a great. I love it when we can show people a little bit of scripting, a little bit of like you don't have to do anything because Binja does it for you too for a lot of those obfuscations.
Yeah, I'm also very excited to show off our product for these two challenges because this works really, really great. Like, I mean, in the previous years, we also worked great, but not to the point that I want to do a blog post and also a live stream to show off.
Yeah.
This year, this challenges and also these new awesome features are out there to help us deal with this obfuscated code.
So we got one question, which is how do we change the value of the structure? So just as a note, the first thing I did was when I saw this first virtual alloc here, I just on the return value of it, I hit S to create a structure, and it asked me how big to make it, and I knew that it was OX58 because that was the parameter to virtual alloc, and then I called that global buffer, partly because Xusheng mentioned that was kind of used that way, but we can also see this one is just storing these other pointers. So this other virtual alloc of hex 4000, hex 4000, hex 1000, those get written here to these offsets. I can hit just S on each of these. Actually, I don't even have to do that. One thing I can do over here is I can call this one a global, and then I can, if I right click on that, you can create all members for the structure. So that'll just create a field of these certain sizes. But what I really want to now do is say, well, this is actually a pointer to a struct that's hex 4000. Right, so I can come over here and I can create another new structure and call it first buffer and make it hex 4000. And then I could make this field 30. I can hit Y on that and change the type of that to struct pointer to, what do I call it? First buffer. What am I doing wrong? Or is it just struct first buffer? I feel like I need to give it a, yeah, pointer. What am I doing? Is that it? No. It's a pointer to the first buffer, right? See, this is why I'm bad at. There we go. There we go. So now we can see we've created this field 30. Hit N on it, we can rename it. So now it's a pointer to this struct burp. So now if I start seeing references later on through that, they'll be members of this other struct. You also see this one is just all padding now that kind of gets, instead of just showing you hex, a lot of zeros or question marks rather, it's going to do that. But we can edit this or add things like add this as references to it. In fact, actually, we might even have references now. Okay, so it didn't actually find any references to it in here, but that's what we would essentially do, is we would go through and we'd make each of these pointers to these other buffers. And then we could start
these buffers do get cross-referenced once you create some other functions and maybe you proceed further into the analysis. And this is very helpful for this challenge. And if you don't do the cleanup of the code and also fix up the stack, you won't get this. So it's important to just clean up the data file as much as you can so that all of the original features, I mean, the thing we have for not obfuscated code can work in the typical way. Like if this is a compiled binary, regular binary, you wouldn't think having cross-references is a privilege.
Yeah.
But many people just suffer from this because they don't clean up to the point where it's good enough. So they just have to either track it by themselves or just get screwed up. All right.
And then so there we can actually even make offsets in the third buffer. Anyway, yeah. I think I actually did the wrong type, but that's all right. That's the general process. And then still definitely some hard work left. But thanks everybody for joining us on a morning or night stream. It's a little bit different time. I hope if you're watching the VOD later, let us know what you thought in the comments. And otherwise, we'll be back some other time. So thanks, Charles. Yeah, really appreciate that. Xusheng did awesome work, and I think Binja's really showing off well with a lot of these challenges, which is exciting. More and more, we're starting to see like some huge advantages compared to a lot of other tooling. So that's pretty exciting. All right. Well, thanks again, Xusheng. I know it's late, so we'll let you get to bed and have a good weekend. Thanks, username. Everybody else, we'll see you next week.
Thank you, Jordan. Thank you, everyone. And looking forward to more work with obfuscated code. See you.
Awesome. Take care, everybody.